So a little while back, I created my Pern stack tutorial video, and I got a lot of feedback from you guys asking to make a deployment video or a video on how to deploy this full stack application. And so that's what this video is going to be for. I'm going to show you guys how to deploy this application. And we're specifically going to deploy this on a Ubuntu server. And we're going to deploy the front end, the back end, and the Postgres database on one Ubuntu server. And I'm going to show you guys how to deploy that Ubuntu server on an AWS EC2 instance. Now, you will need an AWS account, but keep in mind that if that's not an option for you, if you don't have an AWS account or you don't want to make one, 99% of the steps that I go over are just going to be specific to setting this up in Ubuntu. So if you have an Ubuntu server on a DigitalOcean droplet or an Azure virtual machine or a GCP virtual machine, or even a local Ubuntu server, you can follow along and do it on there. These steps are going to work on any Ubuntu machine. It doesn't have to run on AWS. I just chose to use AWS because I see a lot of other videos going over how to deploy it on Heroku or DigitalOcean Droplet. And so I just wanted to make one for AWS because there just isn't as many videos. Now, for anyone that hasn't seen my Pern stack tutorial and wants to actually learn how to make that application, I'll make sure to include a link in the description. However, for this video, you don't have to actually go through that project video, that tutorial. Instead, what I've done is I've uploaded all of the finalized code onto this GitHub repo, and it's going to be a different one from the one I included in the link of my Pern stack video. I did make a few small changes, so definitely check out the code from this specific repository if you want to follow along. The main difference is I removed the .env file, so I didn't check that in. That's usually how you would do it. In an actual application, you want to avoid committing your environment variables into your GitHub repository so that your passwords aren't exposed within the repo itself. But if you take a look at this repo, I created a very detailed README. And so this is going to actually walk you through step by step on how to install Postgres, how to get your code copied over to the server, how to set up an Nginx web server, and how to deploy everything step by step. So you don't even need to watch this video. If you like reading, you can just follow along, and this is going to walk you through it step by step. However, if you do want to follow along, then I'm going to walk you through this as well. And obviously, because this is a video format, I'm going to make sure to really go over what each line is doing, what each config is doing, so that not only are you learning how to deploy this application, you're also learning how to work with Nginx, how to work with SSL, how to work with a lot of the other tools that you need to know to actually deploy this application. And so I think that's enough of an intro. I've set up a few slides just to kind of go over how we're going to set up our application. And, that's only going to take a few minutes. And then afterwards, we can go ahead and log into AWS, create our virtual machine, and get started with deploying this application. All right, guys, so let's go over how our application works in our development environment on our local machine. And then we'll take a look at how it's going to operate in our production server. And so this diagram right here outlines how our application works on our local dev server. And so basically, we've got our React application, and we know that that's going to run on localhost port 3000. And so, if you go to that address in your web browser, it's going to take us to our React application. And when our React application wants to talk to our backend, it's going to send an HTTP request, either GET, POST, PATCH, whatever method it needs to send. It's going to send it to localhost :3001, and then some route that starts with API/v1. It may be API v1 restaurants or reviews, depending on what data it needs. And when it sends that, it's going to reach the Express server, which is listening on localhost port 3001, which is what the request is coming in on. And then based off of that, it can, if it needs to, it can query the database by going to localhost and then port 5432, because the Postgres server is going to be running on port 5432. Now, the important thing to remember is because these two are running on different ports, logically, the React application and the Express application think they're on two different machines. And we know it's on our local host, right? It's on our local machine, but because it's running on a different port, it's almost treated as a different machine. It would almost be like a different IP address or something like that. So the way it works in development is that logically they're going to act as if it's two different machines sending requests to one another. And that's why we needed to set up cores for our development environment. Now, once we go to actually deploy our application, it's going to operate a little bit differently. And so we're going to deploy it on an Ubuntu server. And what we're going to use is Nginx. Now, Nginx, which is represented by this big orange block right here, is a web server that you can install on a Linux operating system. It's a very powerful, feature-rich web server. However, the way everything's going to operate with Nginx on this Ubuntu server is going to be a little bit different. And the first thing I want to point out is I actually purchased a domain name just to show you guys how to set it up with an actual valid domain name. So I bought the domain name sanjeev.xyz. And I'll walk you through kind of how to get a domain name and how to set up the DNS so that traffic gets redirected to your server. I'll cover all of that. But the important thing to consider is that React and Express, when we go to deploy, they're going to think that they're actually on the same machine now. And that's important because if you go to the slide above, remember, they're operating on 2 different ports. But when we go to deploy this, they're going to think they're on the same machine so that we don't actually have to specify a separate port. And that's going to be important because in React, when we send our API request, we're going to have to change the URL. So instead of sending it to https:/localhost 3001 and then /API v1, we just send it directly to /API v1 because it knows it's on the local machine. But anyways, with Nginx, we're going to configure it so that if we get a request for https:// and then the domain name that you purchased or I purchased, with the /URL, so just the root URL, no other path, it's going to take that and it's going to forward that request to the React application. And so it's going to basically return the index.html that the React application creates. Now, if we get a request going to https://sanjeev.xyz, and then anything that starts with the /API, so it doesn't matter what comes afterwards, if it starts with the /API, we'll configure Nginx to forward that directly to our Express application. And our Express application is still technically listening on port 3001. However, all of that's extracted away from the client. So everything's going to be going through Nginx. Nginx will just forward it to the Express application, and then the Express application can then obviously query the database, which is also going to be running on the same machine. So I'm going to show you guys how to set that up with Nginx. It's really simple. There's just a couple of configs that we got to add. And you'll see that the overall deployment process isn't too bad. And once you get the hang of it, you'll see that it's pretty easy to deploy and you'll be able to customize it depending on what you're ultimately trying to accomplish with your application and whatever specific you need for your app. All right, so let's head on over to our code. There's going to be a few minor changes, actually really just one minor change that we have to make to our application to make sure that when we copy our code over to our production server, it's going to operate the way we want it to. And so just to reiterate how our application works, we've got our Express server, our backend, running on port 3001. And then we've got our React application. I don't know if it's going to tell us in the log, but it's running on port 3000. And we can verify that by actually going to localhost port 3000. And we can see the React app being delivered to our web browser. And so let's start off by taking a look at our backend. So all of our backend is stored in our server code inside the server directory. And really, there isn't much code, so everything's just in the server.js file. And if you just take a look at this, let's just make sure that there's nothing that we would need to change from a URL or path perspective because it's not going to be running on our local dev server. It's going to be running on our production server. And so one thing you notice right away is that we've kind of already prepared our app to be production ready. When we set the port right here, we basically said that if the environment variable of port is set, we're going to use whatever that value is. However, if it's not set, we'll just default to 3001. And if we go to our environment variable file, the .env file, you'll see that we are already setting it to port 3001. So it's going to grab port 3001, and that's going to be the port that we're going to use. However, in production, we can choose what port we want to use. Right? You can pick whatever port, and you'll see the way we set up Nginx. We can choose to use really any port. So when we actually go to deploy it, we can do 4001, 5000, 3001. I'm just going to do 3001 because that's just what we've already been doing, and there's going to be no issues with using port 3001 in production as well. But there's nothing else that really needs to change because if you look at how we access our database, the credentials for logging into our database aren't really set anywhere in our code. We used environment variables for that. So you could see here the PG user, the PG host, the password, the database, and the Postgres port are all set based off of environment variables. This is one way of connecting to your database. If you take a look at the PG library, we can statically define it as well. But because we chose to use environment variables, as long as we set these environment variables with the correct values when we go to production, everything should work without issues. So really, so far on our backend, we don't need to touch anything. We don't need to change anything. The only changes that we need to make are going to be on our front-end React app, and it's going to be under the APIs folder. So if you go to APIs, this is where we're basically telling React, what address should we send our API requests to. And so you can see here the base URL for Axios is going to be http://localhost port 3001/API/v1/restaurants. So all API requests are going to have this URL defined as the base URL. But we're going to change that a bit. So what I'm going to do actually is I'm going to create a variable, and I'm just going to call this base URL as well. And I'm going to set that equal to this string right here. And I'm going to now reference that URL, that variable. Right? So up to this point, we haven't actually changed anything. Functionality-wise, exactly the same. And with JavaScript, when the key and the value are the same, we can actually just remove this, and that's going to be the equivalent of just putting that in there. So once again, still nothing has changed. Now the issue comes when we go to deploy, this URL is not going to exist because our server isn't going to technically be running or reachable on localhost port 3001. So if it tries to send an API request to this URL, it's going to fail. And so what we have to do is put in a conditional statement saying that if we are in production mode, then we're going to use a certain URL for our API requests. And if we're in a development mode or any other mode, we're going to use a different URL. And so I'm going to use a ternary operator. But basically, the logic behind what I'm trying to do is we're going to use an environment variable to dictate when we're in production mode. And it's standard procedure to use an environment variable called node_env. And so when we actually go to deploy our React app, you'll find that the node_env variable will be set to production when we deploy it. So when we actually build all the files. Right now, node env is going to be set to production. Development, when we're in development mode. But when we go to production, you'll see that it's going to be set to production. So we can just do a check on what the value of this variable is to determine, are we in development mode or if we're in production mode. And so what we want to say is, if we are in production, then we want to use the base URL of /API/v1 and then /restaurants, right? Because remember, our Express server is no longer going to be reachable through localhost port 3001. It's going to be reachable through directly on that same machine. So we don't need to go to a separate port. So we can just pass in the URL. And then we can say else base URL is going to equal whatever it was before. So if we're not in production mode, we're going to use the same exact URL. And so let me comment this line out. And we can just say const base URL equals, and then we're going to use a ternary operator. So we'll say if process.env, so this is how you grab an environment variable, and then node_env equals production. Then we want to set the base URL to API/v1/restaurants. However, if it's not production, then we want to set it back to this. All right, so hopefully that made sense. But that's all we really need to do. And that's it. So for our React front end is now ready for deployment. We don't really need to do anything else. All right, so let's go ahead and log into the AWS Management Console, and let's work on getting that Ubuntu server deployed within AWS. And so the service that we're using within AWS is called EC2. So that's what's going to allow us to basically create a virtual machine in the cloud. And all you have to do is just search for EC2 and just select that. And before we create our EC2 instance, the first thing that we have to do is set up key pairs. And so by default, when you want to be able to SSH or connect into any of your EC2 instances that you deploy, AWS wants to use certificates. And so here you want to go under key pairs. I've got a few key pairs already created. If you've never created one, then this is going to be an empty list. And go ahead and just create a new one and give it a name. Give it a meaningful name. And by the way, you can reuse the same key pair for all of your servers if you wanted to. So I'm going to call this one Yelp. And I'm going to select PEM format. And then I'll hit create key pair. Okay. And you'll see that right away, your web browser is going to download that PEM file. And it's important that you store this file someplace that's convenient. Okay. You don't want to lose that file. That's how you are able to actually SSH to the machine. All right. So now that we've got our PEM file downloaded, let's go to instances and let's work on deploying an EC2 instance. You'll see that I have two instances right now. One in a stop state, one in a running state. If you don't have any EC2 instances, then you'll just see this section blank. So let's hit launch instance. And we want to search for Ubuntu. Okay, and we're going to deploy this on Ubuntu 20.0.4. And the reason I chose that is because, it's the latest version. Might as well show you guys how to do it on the latest version. Keep in mind for a couple of the steps, if you guys decide to roll out with 18.04 or 16.04, a couple of the steps will be different. I think that's mainly in the SSL portion of things. But a majority of the steps should be almost identical. But if you do want to just follow along with what I'm doing, then make sure you select 20.0.4. You're guaranteed to not have any issues. So we'll select that. Go ahead and select your instance size. I'm going to select the T2 micro because it's free tier eligible. So that's going to be one of the cheaper instances. And then let's go to configure instance details. And I usually leave most of these things as default. The only thing I really just want to change is the tags. And so this is where we can give our EC2 instance an actual name. So you want to give the key to be name with a capital M. It's important that you select it with a capital M. And then give whatever name you want to give for your EC2 instance. So I'm going to call this Yelp app. And then we can hit review and launch. And then hit launch. Now here you have to select the key pair that you created earlier on. So choose an existing key pair. And then I'm going to select Yelp. And then you have to select this acknowledgement. And then we'll launch the instance. All right. And if you select view instances, it's going to take us back to the main instances section within the EC2 page. And so it's going to take maybe a minute or so for the actual EC2 instance to deploy. So we'll give that a second to finish, and then we'll continue with connecting to that server and getting our code copied over to the machine. All right. And so once your EC2 instance has been deployed, open up your terminal. And it doesn't matter if you're on a Windows or a Mac machine. The command to connect to or SSH to the EC2 instance is going to be the same. What you want to do is SSH, and then you want to do -i. So the -i is what's going to allow us to provide a specific PEM file that we're going to use to connect to the machine. And if you recall, this is that PEM file that we downloaded. And now we need to pass in the path towards that PEM file. So like I said, make sure you keep that PEM file in a folder that you can reach. That's in my downloads directory right now. So I'll do downloads. And then yelp.pem. Keep in mind, I'm on a Windows machine, so we use, I can't remember, is that a / or / That's a backslash. But on Linux, you're going to use /. All right, so now we have provided the path to our PEM file. Then we want to pass in the username that we want to log in as. And by default, on Ubuntu machines in AWS, the default username to connect to is always going to be Ubuntu. And then you do @, and then we have to provide the IP address or the public IP address of the machine. And within the AWS console, you'll see under IPv4 public IP, this is going to be the IP address of our machine. So we can just take that and copy it. and then paste it in there. And then hit enter. You'll probably get this warning right here. Just hit yes. And there you go. So once you see this output, it means you've successfully logged into the machine. Now, I don't actually like to use the default terminal for Windows, so I'm going to open this up in a different terminal. Functionality-wise, doesn't change anything. It just allows me to use something I'm a little more comfortable with. All right, so now that we're connected to our Ubuntu server, it's time to start configuring it so that it can host our application. And at this point, you can take a look at the README and just follow along with this. I'm going to, for the most part, follow along with the README. However, there's going to be a few instances where I kind of hop around a bit. And I'm just going to do that for, I guess, explanation purposes. It's going to help me explain what certain commands and configs do a little bit more. In this document, I tried to make it as descriptive as possible. But ultimately, this README is just to make sure that you guys can get it up and running as quickly as possible. And so my priority wasn't explaining things in this. It was just to give you the commands that you need to set it up. All right, so in the README, the first thing that we're going to do is set up Postgres. And to set up Postgres, we want to make sure that we update our packages and our repository. So we do a sudo apt update and a sudo apt upgrade, and then we pass in a -y flag. That's just going to make it so that we don't get a prompt asking if we approve whatever changes it needs to make. So we can just copy this line directly. And this is going to take some time as well. So if it takes a little while, don't worry, nothing's broken. It's just got to update all of the packages that are already installed. All right, so once that's complete, the next thing we want to do is install Postgres. And so to install any package, you do sudo apt install and then the name of the package. So there's going to be two packages. We want PostgreSQL as well as PostgreSQL-contrib. And then we can pass in the -y flag so that we don't get any prompts once again. All right, so now that we have Postgres, let's try to connect to it. So if I type in PSQL, let's see what happens. And so, when we do PSQL, it says it could not connect, and that's because there isn't a role called Ubuntu defined on Postgres. So let me quickly explain what that means. When you try to connect to a Postgres database on the same local machine, what happens is by default, it makes use of something called peer authentication. So it taps into the kernel and figures out what user you're logged in as and tries to connect to the database into Postgres using that same username. So we're logged in as Ubuntu. So if you do who am I, it's going to tell you the username of the user that you're logged in as, and it's also prepended at the beginning of the prompt. And so it's going to grab this and it's going to try to log into the Postgres database using that user. Now this is a fresh install of Postgres. There's no user called Ubuntu installed on it. Postgres by default installs one specific user, and that is a user called Postgres. And not only that, for authentication, like I said, it uses something called peer authentication. And so it's once again going to tap into the kernel and use that user to log in to Postgres. And so what it actually has done when we installed Postgres, it also created a user on our Linux machine on Ubuntu. So if I type in sudo cat /etc/passwd, this is going to list all the users that are installed on our local machine, not on Postgres, but on our actual Linux operating system. Right? And so you could see the Ubuntu user that, was installed when we set it up within EC2, and it also created a Postgres user. So we can log into this Postgres user. So if you type in sudo -i -u, and then the user that you want to switch to, that's going to be called Postgres. You're going to see that we've switched to the Postgres user, and the prompt changes. And if I type in who am I, it's going to tell us that we are now Postgres. And so if I type in PSQL, we can now log into our Postgres database. And we log into a specific database called Postgres as well. And if we do a /d, whoops, not /d, /l, it's going to list out all of the databases. And so you're always going to have the same three databases that are configured by default on a fresh install. We're going to have one called Postgres, we're going to have one called Template0, and one called Template1. Now, the way we're going to set up everything, including our application, is everything's going to run through our Ubuntu user. So our Ubuntu user is going to be the one that ultimately starts our Express application, and the Ubuntu user is going to be the one that's going to try and connect to the database. So I want to create a user that's also called Ubuntu within the Postgres database, so that we can log in and connect to it. So let's exit out of Postgres, and you can do a /q. And if we take a look at the documentation, there's a command called create user dash dash interactive. And make sure you're still logged in as the Postgres user, because if we move back to the Ubuntu user, he obviously doesn't have access to the Postgres database, so he can't create a new user for himself. So we'll do create user and then dash dash interactive. So this will give us a whole bunch of prompts when it comes to setting up this new user. So we have to give it a name for the user. And once again, I'm using the term user, but within Postgres, it's called role. So I'm going to call this Ubuntu to match the name of our actual operating system user. Then do we want to make him a super user? And so I'm going to make him a super user just for simplicity's sake. This will give him full, unlimited privileges. It's almost like being a root user within Linux. So when you're a super user, you can create, delete, modify all users. You can create, modify, delete databases. You can do anything. So I'm going to hit yes. However, if you wanted to do this really the proper way, you probably don't want to make him a super user. You probably want to make him a regular user and make sure that you only give him access to the exact databases that he needs access to, just from a security perspective. But I don't want this video to go on for too long. So just for simplicity's sake, just make him a super user. And let's log back in by typing in PSQL. And if you do a /du, we should see that we now have two users installed. We've got the Postgres user and we've got the Ubuntu user. And you can see he's a super user, so he can create roles as well as databases. All right, so let's exit out of this, and let's exit out of the Postgres user. So if you just type in exit, it's going to move us back to the Ubuntu user, and we can verify that by looking right here, but also by typing in who am I. And so now confirming we are the Ubuntu user. And let's try to log into Postgres now. So if I type in PSQL, let's see what happens. Looks like we still get an error, right? But the error is different this time. The error says that it could not connect to a database named Ubuntu, right? And so what happens is, by default, when you just type in PSQL and you try to connect to Postgres, Postgres automatically tries to log you into a database that matches the name of the user. So since my username is Ubuntu, it's going to try to log me into a database called Ubuntu. However, there's no database called Ubuntu. Remember, there's only these three databases. So there's a couple of things we can do. We can create a blank database called Ubuntu when we're logged in as the Postgres user, obviously, because we need access to Postgres. But that's a little messy. Why go through the hassle of creating an empty database just so that we can conveniently log into Postgres? Instead, what we can do is we can just type in PSQL, pass in the D flag, which is going to allow us to specify a database. And if you're wondering where I'm getting all of these extra flags to add to this command, you could just do a -- help. And that's going to show you all of the different flags that we can pass in. So if you do -d, that's going to tell you what database you want to connect to. And so we can do PSQL -d and then pass in the name of a database that we know exists for a fact. And we know there's a database called Postgres. And there you go. We're logged in. And we're logged in as the Ubuntu user. And if you want to see the connection information, you can type in /con-info, I think. And this is going to let you know you're connected to a database called Postgres as user Ubuntu, and so on. All right, so let's exit out of that. And you'll notice that there's no actual password that's being asked of us when we log in. And that's because of that peer authentication that I mentioned. When we try to log into our Postgres database, it's going to tap into the kernel and try to log you in as the user. Because if you're logged in as that user, then you should be able to have access to that user within the Postgres database because they match. And if you go to /etc, and then I think Postgres, and then whatever version that you have installed, do an ls go to main. There's a config file where if you don't like that peer authentication behavior, You can modify that in this pg_hba.conf. I'm just going to do a cat, so that's going to print out the contents of this file. And you're going to need sudo privilege. And you'll see that for local connections, it uses peer authentication under the method. All right. So if you don't like that behavior, and if you always want to be prompted for a password, you can change that to MD5. So MD5 will prompt you for a password. However, don't worry about this. When we actually go to deploy our application, it's not going to be using a local connection. It's going to think it's connecting from a different machine or a different IP address because it's coming, from our Express server. So it's not actually going to use local authentication, and it's going to actually require a password. So you don't really need to change anything for that. But I did want to point out to you guys how to change this if you didn't like that behavior. Now, our user still does not have a password associated with. Now, our user, the Ubuntu user within Postgres, still does not have a password. So let's go ahead and create a password for the Ubuntu user within Postgres. So we're going to do PSQL, and remember we have to pass in the name of a database that exists so that we can actually connect. And the command to create or change a password is alter user, then the name of the user, then the password field, and then we pass in the password that we want to use. So I'm going to do alter user, then the name of the user is going to be Ubuntu, and then password. So we're going to change the password field, and I'm going to set this to be password123. Not very safe, but let's keep it simple. Okay, and if you see alter role, that means it was successful, and we can exit out of that. So now that we've got Postgres installed, the next thing that we have to do is we have to recreate our database schema. And that includes, creating the Yelp database or the database named Yelp, creating the restaurants table, creating the reviews table. And so you're probably thinking, oh man, did I write down all the commands needed to do that? Well, I actually don't have the commands saved that was necessary to create those databases, but Postgres has a tool called pgdump where you can dump the database schema and then you can import it in another instance of Postgres so that you can recreate an entire database schema with just a couple commands. And not only that, we can dump not only the database schema, we can also dump the data within your database as well. So if you want to move over all of the restaurants that we have in our local dev server, we can move that into our production server as well. And that's actually what we're going to do just so that we already have some pre-populated data. So now let's move back to our local dev server. So you want to open up the terminal, right? Make sure you're connected to the terminal of your local machine and not to the Ubuntu server. Okay, and so go ahead and navigate to any directory that you want. We're going to have to save a file, but the command that we want to run is called pgdump. So this is going to dump the contents of either all of your databases or a specific database. And so I've provided this command, and let me just quickly go over what all of the different flags are. So here I pass in the -u flag, and this is going to be the user that we want to log in as. So in my local dev server, I just have Postgres user. I didn't create any of the users, so we have to specify the specific user we want to log in as, or else it's going to try to log in as whatever user we're logged in on the Windows machine because it also does peer authentication. Then the -f is going to say, it's going to specify the specific file we want to store this dump into. So this is going to create a Yelp file called yelp.pgsql, and it's going to get stored in this directory, and it's going to store the contents of the Postgres dump, and then pass in the -c flag, which is going to make sure it includes the extra create database command within the schema. If you don't pass this, it doesn't provide that. However, I found that it doesn't really help. We'll still have to manually create the database anyways, so you can probably leave that off. And then the final thing that we have to pass in is the name of the database that we want to dump. Now, this is technically optional. However, I don't want to dump all of the databases that I have on my local dev server. I've got a lot of different databases. So I think it's good to just dump the specific database that you're interested in. So I'm going to dump the database called Yelp. And if you guys decided to use a different name, then make sure to update that with whatever specific name that you use. I'm going to do pg underscore dump dash u, that's a capital U, and then dash f. I'm going to call this yelp.pgsql dash capital C, and then yelp. And it's going to ask me for the password to connect. So I'm going to pass that in. And then after that's done, it should create a file. So if you're on a Windows, you can type in dir. If you're on Linux, type in ls. And you can see at the bottom, I've got my yelp.pgsql file. So now I need to take this file and copy it over to my production server. And so there's a command called scp, and that's going to copy a file to the production server. And this is going to be a little bit of a long command. So we do scp. And remember, our authentication method for SSHing is using that certificate. So we're going to have to do the same thing that we did for SSH for SCP. So we pass in the -i flag, and we pass in the path to that yelp.pem file. And I think it was in downloads and then yelp.pem. That's right. And keep in mind, right, when it comes to specific paths in Linux, it's going to be a /. But I'm on Windows, so it's going to be a \. Okay, so now the next two arguments that we need to pass is the source file and the destination. Okay, so the source file is going to be this yelp.pgsql. So I'm going to pass in yelp.pgsql. And then the second argument is going to be where do I want to copy it to? So this is going to be copied to a remote machine. So we have to pick the user of the username that we want to log in to that machine as. So we always log in as Ubuntu. And then we do @ and then we need to grab the IP address of that machine. And I already forgot what it was, but we can always go to AWS and grab that info. And this is the IP right here. Okay, then you do :, and then now we have to pass in the directory we want to copy the file over to. So I'm going to copy it to /home/Ubuntu. Keep in mind, this isn't an actual requirement. You can pass it into any directory that you want to. All right, and then we'll get the same prompt like we normally do and just hit yes. Okay, and if it was successful, you should see this this line that looks pretty similar to this, where it says 100%, which means 100% of the file got copied over, and everything should be good to go. So if we go back to our SSH session where we've logged into the production server, go to that directory, so /home/Ubuntu. And a shortcut to getting to that specific directory, you can also do cd and then pass in the little tilde, and that's going to take you to your home directory. So if I do ls, we can now see the yelp.pgsql file. All right, so we've got this file in there. Now let's import it into our database. And the first thing that we have to do is, first of all, we have to manually create the Yelp database. I was trying to find a way for this file to automatically create the database for us as well, but it just never seemed to work. So we'll have to do one thing manually. So let's do PSQL and then pass in the Postgres database just so we can log into it. And to create a database, we can do create database, and then we'll call it Yelp. And we can do a /l. And we can now see that we have a empty Yelp database. We'll exit out of that. And now the command to import a database is going to be this right here. You do PSQL, then the name of the database, and then you do this > sign, and then you pass in the path towards this yelp.pgsql file. So PSQL, Yelp, and then it's going to be in /home/Ubuntu, then yelp.pgsql. And you should see a whole bunch of output. If you scroll up, you may see an error or two, but it should not cause any issues. There's just some kind of random thing with this locale name, which it's not going to impact anything. As long as everything else gets set, you should be okay. But just in case, let's go back into Postgres. And now we can actually connect it directly into our Yelp database. And we can do a /d to see all the relations. And now we've got our restaurants and our reviews. And if we do a select star from restaurants, we should see that all of the restaurants from our local dev server got copied over. Yep, and there you go. So it looks like the import of the database went just fine. All right, so that's about all we have to do when it comes to Postgres. We're actually done with the Postgres installation. We've set it up so that it will work just fine. It's running on the default port of 5432, and that's what we're going to use for our application. If you did need to change that, just feel free to just Google it. It's not a hard thing to do, but I see no reason to have to change that. So we're just going to run with the default port. All right, so now that Postgres is installed, the next step is going to be to copy our application code onto our production server. And so first, we need to decide where we want to store our code. This is something that doesn't really matter too much. Just pick a location. So what I'm going to do is I'm going to create a folder called apps within my home directory. So if you want to figure out where you are within the Linux CLI, you can just type in pwd. So I'm in /home/Ubuntu. And so I'm going to type in mkdir to create a new file. And I'm going to create a new directory. We'll call it apps. And then I'm going to move into that directory by typing cd and then apps. Right? And if you do a pwd, you can see that we're now in home/Ubuntu/apps. And then within apps, I'm going to create a new folder that's going to contain all of our application code. So I'm going to do mkdir, and then what did I use in the example? I called it yelp-app, so I'll do the same thing. All right, so now we have a folder called yelp-app, and I'm going to move into that folder. And now we're going to copy our code from our repo. So let's go back to the repo. I'm going to just click that button right there. And we can copy the code. So if you select this dropdown, select HTTPS, and just copy it. So now that's copied into our copy buffer. I think that's what it's called. And now we can do a git clone. So let me move on down. And we just type in git clone, paste the URL that was provided. And then what we want to do is do a space and then a dot. So that's going to copy it to this directory. All right. And so now if I do an ls, we should see the README, the client folder, and the server folder. So we've got our code copied over. All right, so now that we've got our code copied over, we won't actually be able to do anything with our code because we don't have Node installed. So logically, the next step is going to be installing Node. Okay, and to install Node on Ubuntu or Linux, it's going to be a little bit different than when we installed it on Mac or Windows. So let's go to the Node website. I'm going to show you guys where to go to actually get these steps for that. So if we go and then select other downloads under the current, and we want to scroll down to installing Node.js via a package manager, right? And package manager is that apt command that I mentioned earlier that we use to update our packages. And then we want to select Debian and Ubuntu-based Linux admin. And here for Debian and Ubuntu, we have to click on this link. And it's going to take us to this GitHub file. And so here, it's going to show us how to install Node on various operating systems like Ubuntu. So let's go to, just keep scrolling down, and we're going to install Node.js version 14 because that's the latest. And on Ubuntu, there's only two commands that you need to run, this command and then this command. So we can just copy these directly. And we can take this and copy that. And once this command is run, we'll have Node installed. All right. And just to make sure our installation was successful, just type in node -- version, and it should tell you what version of Node is installed. And keep in mind, guys, you might have a later or a more recent version of Node. Don't worry, that's not going to be an issue. Okay. Now that we have Node, let's go to our Yelp app folder. All right. And this is where all of our code is. And let's go to our server directory. And if I do an ls, you'll notice that we've got most of the files that we have that we had in our development server or in our on our local machine. However, there's one thing that's missing, and that's the Node modules folder. And that's because when I committed all of my code to GitHub, I used a .git ignore file to make sure that we excluded node modules, and I guess I don't have it listed here, but I also excluded the .env file. So we don't have any of the node modules, and that's the way you do it, because there's no reason in copying over all of the node modules. Instead, what you'd want to do is in our production server, we can just do an npm install, and it's going to install all of the node packages that we need. There's no need to have to commit all of those into Git. It would just take an unnecessary amount of time. All right, so we've got all of those installed. And so at this point, we can actually test to see if this works. So if I do a node and then server.js, you should see that, we've got the console.log. It looks like our application's already working fine. However, keep in mind that in a production environment, we never want to run Node directly. You'll never actually see this in production. Instead, we're going to use a process manager. And there's a process manager called PM2. If you want to take a look at the documentation for that, just search for PM2. This is the documentation for it. But to install PM2, all you have to do is npm install PM2. And then you want to pass in the -g flag because we're going to be installing it globally. So let's stop this. I'm going to do Control C. And I'm going to do an npm install. What was it called again? PM2-g. So PM2 and then -g. And so PM2 is going to be responsible for making sure our Express app is working properly. It's going to be responsible for making sure that if our Node app crashes, it's going to restart it for us. And it's also going to make sure that, when our Ubuntu server reloads for some reason, whether there's a power outage or we needed to upgrade it, it automatically starts our application when it reboots. And you'll see that I got an error, and that's because the command I ran, because we're using the -g flag, we're going to need to do sudo at the beginning. We need root privileges to do that. All right, so now that's installed. We can use PM2 now. So let's, I'm going to go back to my home directory. And I didn't actually need to change to my home directory, but now to start our application, our Node application using PM2, all you have to do is type in PM2 start, and then you need to provide it the path to that server.js file, which is what we need to run to start our backend. So I'm going to pass in the path. So it's going to be at apps, Yelp app. Then it's going to be under the server directory. And then it's going to be under server.js. All right. And so it's going to print out a whole bunch of information and also gives us this nice little output on the current status. So you can see it created a process for us with an ID of 0. It gave it a name of server. You can see right now it's using no CPU pretty much and only 28.7 megabits of memory. All right. And so that's all you technically need to do to get your backend started. However, there's a few other commands I want to show you guys with regards to PM2. So if you want to stop a process, you can do PM2 stop, and then you can pass in either the name or the ID. So I'm just going to give it the ID of 0. Right. And so now you can see that it's been stopped. And if you ever want to check the status of your processes, you can do PM2 status, and it's going to print out that same information. And keep in mind, guys, you can spin up as many processes as you want. So if you wanted 12 different, node backends, you can do that with PM2. You just do PM2 start, and then, wherever the first server.js file is or wherever your code is hosted, then you do PM2 start again and point it towards the other project code, right? So in this example, we only have one backend, so we're just going to have one process. But I just want to make sure you guys understand that, you can spin up as many processes as you want. If we want to delete a process, we can do PM2 delete and then the ID again. And there you go. It's deleted. We've got nothing else. But let's go ahead and create that same process again. So PM2 start, and then we got to pass in the path to that server.js file. And this time I'm going to pass in a new flag. I'm going to pass in the name flag. And this is going to allow us to give it a more suitable name for our process, because server, I don't know what that is. So we can call this Yelp-app. And so now when it starts the process, it gives it a more meaningful name. Now, this is great and all. However, if we reboot our Ubuntu server, you'll see that PM2 will not automatically start our app for us, which, I mean, if our server accidentally reboots for whatever reason, we would ideally want it to power up our application as the server comes back online. So let's configure it to do that. It's really simple. And I've got the configs or the commands needed right here in this README. And so all we have to do is do a PM2 start. I think it's PM2 startup. Yep, PM2 startup. And it's going to print out this command right here. So we have to take this command. Let me make this bigger. I hate it when it wraps around. Okay, and so I'm just going to copy that and paste it. And there you go. Now PM2 status. You'll see that we've got our application running, and we want to take a snapshot of all of the processes that we want to get started up on startup. So what you do is you enable all of the apps that you want powered on during boot up. And in this case, we just have one app. We just have this one. So as long as it's powered up, we then do a PM2 save, and it's going to remember all of the processes that are currently powered on. And so when we reload our Ubuntu server, it should automatically power on all of these processes, or in this case, just this one process. And so just for demonstration purposes, I'm just going to reboot it, and we'll just verify that it's actually doing what we told it to do. All right, after it's finished rebooting, let's connect back to our server. All right, and we want to do a PM2 status. And we can see that the process was powered up by PM2. And there you go, guys. So that's how you ensure that your node backend gets powered up automatically after reboot. And so that's all we need to do with regards to PM2. And that's all we need to do with regards to our backend. The next thing that we want to do is prepare our front end code for deployment. And so we copied the source code. However, when we actually want to deploy a React app, we have to run an npm run build to build our code and create the finalized HTML, CSS, and JavaScript files that'll have been condensed and minified and whatnot. So let's go to our application folder. So if we go to CD apps, and then Yelp app, then we want to go into client. So first things first, remember the node modules folder doesn't get copied over into Git, so we want to do an npm install so we can install all of our necessary dependencies. And once that's done, we want to run an npm run build. Okay, and once that's complete, if you do an ls, you'll see that it's created a new build folder with all of our finalized code. If you go into build, you'll see a couple of different files. You'll see all of your assets. And then you'll also see the final index.html file. So this is the file that we want our Nginx web server to serve all of our users. And so keep in mind, this is the path to that file. You can move this finalized code anywhere onto, on this machine. You don't have to keep it here. I'm just a little lazy, so I'm just going to keep it here and just point the Nginx configs to this specific path. But that's all we have to do for the front end code. The next step is going to be installing Nginx. All right, so let's install Nginx now, and we can do that with the sudo apt install Nginx. And once Nginx is finished installing, the next thing we want to do is make sure that Nginx is configured to be powered on automatically whenever the server reboots. And we can do that with a sudo systemctl enable Nginx. And so we'll paste that in. And now to verify that actually worked, you can do a systemctl status Nginx. And in this output, there's a few things you want to look for. So it's letting us know that it's currently running, and we want to make sure that it's enabled. So that's what that last command did. It set it up for enabled. And whenever it's enabled, that means that whenever this machine gets reloaded and powers on, it's automatically going to bring this to bring our Nginx server back online. All right, so now to actually configure and set up our Nginx server, web server, we want to navigate to the /etc/Nginx directory. Here you'll see a couple of different things, and the main folder that we're concerned with is going to be the sites available directory. And I want to make sure you guys don't confuse this with sites enabled. They sound very similar, but they are two very different folders. You want to make sure you go under sites available. So let's go under there. And if I do an ls, you'll see that we have a file called default. Now, Nginx is a really feature-rich web server, and one of the great things that Nginx can do is it can host multiple websites, multiple web apps, all within one machine. So if you have 10 different projects, 20 different projects, Nginx can be configured to host all of those applications. And the way it does that is by using something that it refers to as server blocks. So you can think of a server block as the config associated with one specific website or one specific web app. It comes with a default server block called default. So traffic, any HTTP request that gets sent to this Nginx server is going to get processed by the default server block. And we can actually see this in action. So if we go to the IP address of our machine, and so go back to AWS, and we'll grab the IP address. And paste it in there. You'll actually see this fail. And the reason it fails right now is because AWS provides us with a built-in firewall that it right now is not configured to allow HTTP traffic. So we need to quickly configure that. And this is something we'll have to do anyway, so we might as well knock it out now. And so let me quickly just show you what I just did there. Go back to instances, select your instance, and then under security groups, select the launch wizard one. Yours might be called something different. It'll be like launch wizard 1 or 2 or 3, depending on how many EC2 instances you have. But this is the default security group that gets created for this specific EC2 instance. And we want to modify this. So let's select the group ID. And we want to modify the inbound rules. So make sure that's selected and then hit edit inbound rules. And you'll see right now there's just one rule, and then it's set to allow SSH, which is port 22 from any IP address. And that is what allows us to connect to the box. But we do need to add some extra traffic or extra rules. So we want to allow HTTP traffic, which is port 80 by default. And we want to allow it from any IP address. And then we also want to allow HTTPS, which is port 443. And HTTPS is just a secure version of HTTP. And we want to allow this from all IP addresses. So let's save that. And now, if we refresh the page, you could see this simple HTML file that gets served by Nginx. So this is just letting us know that Nginx was installed properly. But that's all being handled by the default server block. And what I want to do is let's take a look at the server block, the default server block, and I'll explain a few things on how it actually works. And so there's a lot of configs. Well, there actually isn't a lot of configs. There's just a lot of comments that don't do anything, but that are just there to let you know, if you need to make any modifications and things like that. So a server block always starts out with the word server and then an opening and a closing curly brace. So the closing curly brace is down here. So what we want to do is we want to tell it what port to listen on. So for port 80, which is the default HTTP port, it's going to be listening. And then, for IPv6, it's going to do the same thing. It's going to be listening on port 80. So it can handle IPv4 and IPv6. And since this is the default server block, it also has this extra flag or this extra option called default_server. And so basically, if you get an HTTP request on this Nginx server and it doesn't match any other server block, it'll default to this one. So that's what makes it the default server block. Now this root line is going to tell the Nginx server what HTML file we should return to the client. So here, there's a file under /var/www/html. And that file in this location is what's being served right here that says welcome to Nginx. And we can actually take a look at it real quick. So you go to cd/var /ww, and then what was it, HTML? So under there, we've got a HTML file right here, and we can do a cat of that file. And you can see the HTML for that. So, it says welcome to Nginx. So we know that this is the file that's being served. But back to the rest of the configs. Don't worry too much about this line. This is just saying the list of files that it's going to look for in this directory for it to serve. And so, this file is called, what was it called? index.nginx-debian.html. And so here you can see it's in there, so it can serve that file. This is just providing a list of different files that it'll look for within that directory. But normally, it's just going to serve a file called index.html. And if you recall, when we deployed our React app, it did create an index.html file. So as long as we have index.html in this list, we should be okay. The next line is server_name. So this is going to be the names of the domain names of the applications you want to host. So if you purchased a domain name, you would put it here. So like, let's say if we wanted to create our own Google and we owned the www.google.com, we would put www.google.com here. And that's how Nginx knows what request is meant to go to what application. And that's how it actually hosts multiple applications on one web server. It looks for the domain name in the HTTP request. Right now, since this is the default server block, it just has an underscore saying it can basically serve that HTML file for any domain name that reaches this Nginx server. Then we have this location block. So this is just saying that anything for the root URL, it's going to try and serve a file, and if it can't, it's just going to deploy. It's going to send back a 404. So if I try to go to /test or something, it should send a 404. So that's what that line is doing right there. And then that's about it. Everything else is commented out. So based off of this, it's pretty easy to figure out what kind of changes we need to make to serve our React application. And so let's go ahead and do that. But we got to go back to /etc/nginx, sites available. And we want to create a new file. And we can call this file anything we want. However, it makes sense to name this file the same name as the domain that you've purchased for your application. And I want to show you guys, if I go to names sheep, this is where I purchased my domain name. And let me log in real quick. Where is it? Account, dashboard. And I've purchased this domain right here. I don't know if you guys, it's a little small, but it's called sanjeev.xyz. It's just something that was just really cheap. And so I'm going to call this, the domain name associated with this application that I'm deploying is going to be called sanjeev.xyz. If you purchased a domain name, it's going to be something else, obviously. And so I'm going to create a file and I'm going to name it whatever my domain name is. So sanjeev.xyz. But once again, if you have a different domain name, then name it that, right? It just makes sense to name the file after the domain name, just so that, if you do end up, hosting multiple applications, it's pretty easy to tell which file is associated with which application based off the domain name. And so instead of creating a blank or empty file, I'm actually going to copy the default server block because, 70% of the configs are already there. So there's no need to rewrite all of that ourselves. And so I'm going to do a CP. The CP command is what allows us to copy. And we want to copy the default file to a file called sanjeev.xyz. And we need sudo. And now if I do an ls, I have sanjeev.xyz. All right, so now let's go in and let's let's go ahead and make the changes that we need for that file. And so I like to use the text editor called VI. If you like using Nano, feel free to use whichever one you want. I'm not going to go over how to use the VI or either of the text editors because that would just take too long. Just Google around if you're new to Linux. It's not too difficult. All right, so once again, this looks fairly similar to what we saw in the default server block. Well, it's exactly the same because we copied it. But I'm going to delete all the comments because it just makes things look a little messy and a little more complex than it needs to be. All right. And so the changes we need to make is first things first. I'm not going to make this the default server block. I mean, we could, right? Because right now we're only hosting one application, so you could. But if you did want to host more than one application and you didn't want this to be the default server block, then you would want to remove these two options right here. And we want to do the same thing for IPv6. Okay, and so the next thing we want to do is uh, we want to pass in the location of our React build. I think it was called the build folder. And so I don't remember exactly where it was, but I have it inside this README. It's that extra folder that was created when we ran an npm run build. And so let's go back here, and it's going to be under home/ubuntu/apps yelp app-client/build. So we can just copy this actually. And I'm just going to delete that line and put it in. Spacing doesn't technically matter, but I like to keep things nice and pretty. And we want to make sure that it has index.html, so it'll look for that file. Then the next thing that we want to do is we want to make sure we pass in the domain names under server name. And so my domain name is sanjeev.xyz. And we also want to pass in the www form of that. And finally, if you don't have a domain name, that's okay. You can always just put in the actual IP address of your machine. And so this will allow us to process requests that just go directly to the IP of the server without a specific domain name. So if we go back to instances, we'll copy this. So 54.173.18.115. All right. And if you actually take a look at this README, you'll see the final configs that we need for everything. However, when I go over this section, I don't actually want to write out all of these things right now because I want to show you what they actually do. So instead, I'm going to delete the location block right here. I'm going to show you what happens when we don't have that. All right, so let's save this. Now that that's saved, we want to actually deploy those configs. So we have to enable the new site that we configured. And so we can just copy this line directly. However, keep in mind, if you named your site something different, then you want to update that accordingly. And then finally, we want to do a sudo systemctl restart Nginx so that the changes can take effect. And so now, if I go back to here, remove the /test, we just want to go directly to the IP address, you can see that we get our application. The application doesn't fully work because the backend hasn't been set up fully, or Nginx hasn't been set up to process the backend, but we can see it now works. All right, so now that we've got the base Nginx config set, I want to go back to the slide deck that I covered a little bit earlier, just to kind of reiterate what we want Nginx to do. And so, this is what it was. Hopefully it's big enough for you guys. I don't feel like going into full screen. But what we wanted to do is when we just get the root URL, just the slash after the domain name, we want Nginx to forward this to React. And then if we go down to the next slide, if we get any request that goes to the URL of /API, we want to forward that to the Express API. So let's configure that, and I'll show you guys how that's done. And so what I'm going to do is I'm going to go back to the config file. We want to go back into that sanjeev.xyz. And before you do anything, make sure you do a sudo beforehand. And at this point, what we can do is just copy the configs from here. So this config right here is basically saying that any request to this Nginx server with a URL of /API, just like I said here, anything with a /API is going to get proxied. So we're going to proxy this to HTTP ://localhost 3000. And that's where our backend's running. So that's how we forward these API requests to our backend and then still allow our front end requests to go directly to our React app. And so right now, I'm not going to explain what this does yet. This is, it's kind of doing the same thing, right? So any request with a /URL, it just has this command, but we'll come back to that in a second. I want to set up the backend so that we can actually hit our backend. And we'll just copy this for now. I don't really feel like explaining all of these other ones. Feel free to Google that, but this is for the most part just a copy and paste thing that most people do anyways. And I'll paste that in there. And it got a little mangled. Let's make it a little prettier. Right? And we can then exit out of that. And we can do a systemctl. We'll have to do a sudo systemctl restart Nginx. And so now it should be able to hit our backend. But it's still not going, well, actually, no, this is the one we want right here. So if I hit refresh, it still doesn't work, but that's just because our backend can't reach our database because we haven't set up our environment variables. However, before we move on, there's one minor issue. So if we go to, actually, let's take a look at our development server. So if we click on one of these links, right, it's going to take us to a URL called /restaurants, and then the restaurant number or the ID, and then takes us to that detailed page. Now in our application, if I do the same thing, and that's because right now, by default, if you take a look at the configs from Nginx, we serve the index.html, so it'll only address things that get sent to the /URL, just the slash, right? So it can only process anything that goes to /, and that's why that works fine. And then anything to /API will get properly sent to our backend. However, it doesn't have any configs for, /restaurants, and then the ID of the restaurant. We haven't provided a config, and this is because React is a single page application, and so we want technically all requests to get sent to our React app, and our React app will handle the routing. And so that's what that second location config right here is. This line right here is basically saying that if we can't, if we get a request for any other path, we want to just send it back to the index.html and let React handle the routing for that. So this is something that's specific to React that we actually have to add. So let's go back into that file and let's add the configs for that. And we'll do a sudo systemctl restart Nginx. And I think now if we do a refresh, restaurant/2, right? We don't get a 404 error. Nothing loads up onto our screen, but that's just because our database is not set up properly. Our backend can't reach our database, but we're not getting a 404, so we know that that extra config that we just added is now working, and it's passing that request off to React, and React can handle the routing. But that's all we need to do from an Nginx perspective. The next thing I want to cover is how to set up our domain name, or how to purchase a domain name, because I guess that's something that's good to know. I don't know if all of you guys know how to do that, but I'll kind of walk you through how that's done. Now, to get a domain name, this is something that you have to purchase, and you have to go to a domain registrar. And there's a lot of different domain registrars, and there's a lot of ones that you guys are already probably familiar with. GoDaddy's a really popular one just because they slam you with so many commercials. So if you wanted to purchase a domain name, you can go there. You can purchase it from Google as well. And there's a lot of other domain registrars. What I like to use is the one called Namecheap. So Namecheap is the one that I use. And basically, it's a pretty simple process. All you do is just think of a name that you want, right? Whatever domain name you want, and just search for it. So if you want, let's say I wanted google.com, right? You can search for that, and it's going to tell us that it is not available, right? Because obviously Google owns it. But we can try something else like, if I do Sanjeev123hello.com, that's obviously going to be available. No one wants it. And I can purchase it for $8.88 per year. More popular names are going to cost more. But you have a lot of other options that can make things a little bit cheaper. So like if you get like a .dev or something or a .ai, well, actually that's more, $58 a year. Yeah, it's more expensive for some reason. I don't know why it is. But you can get a .org. So just search whatever domain that you want, and then just add it to your cart, and then just purchase it. It's a pretty straightforward process, like buying anything else. You just have to make sure it's available. But that's all you have to do for your domain name. The one last thing that you have to do with regards to your domain name is set up DNS. So anytime a user sends traffic to your domain name, you have to go to your domain registrar and tell them to forward the request to the IP address of your server. And so, my server, if I take a look at the IP, it's this IP. I need to tell Namecheap, hey, for the domain that I purchased, I need you to send that request to this IP address right here. And the process on how to configure this is going to be different for every single domain registrar. So I can show you how to do it with Namecheap, but I can't show you how to do it with, Google or GoDaddy, because they all have a different UI. So let me quickly log in, and I'll show you guys how to set it up. You'll see that the configs are going to be fairly similar across all of them. You may just have to press a few different buttons, but there's basically two different DNS entries that we need to set up. So let me log in. Where's my account? Go to dashboard. I'm going to select the specific domain, which is sanjeev.xyz. And we want to go to advanced DNS. And there's two rules that we have to put in. So we have to create two different A records. And so, you can just select it. There's a few different types of records. We want A records. And then for under host, we want one to be the @ symbol, and then the other one to be www. And our under value for both of them, we want to put the IP address of our EC2 server. So I'm going to grab this. What happened here? I'll just copy it right here. All right. And then so this is just going to default to 30 minutes for the first one, and then automatic for the second one. I usually just leave whatever the defaults are, and then I'll hit save all changes. And so at this point, the changes do take a certain amount of time to take effect. Sometimes I see it almost instantly, but they do report that it could take up to like 24, 48 hours for these changes to take effect. But we can test this. I'm just going to go to Sanjeev.xyz, and let's see what happens. And look at that. So now, when you go to Sanjeev.xyz, what happens is that request will go to their DNS server. The DNS server is going to then send the request to this IP, which gets sent to our EC2 instance, which then goes to our Nginx configs, and our Nginx looks for a server block that matches that. And if we do a cat Sanjeev.xyz, our Nginx sees that we have a server block that's going to handle requests to Sanjeev.xyz as well as www.sanjeev.xyz. And then it's going to serve that index.html file. So that's all that's really happening. And that's all we have to do from a domain name and a DNS perspective. All right, so now let's set up our environment variables. And like I said before, when we checked in our code into our GitHub repository, we have to make sure that we don't check in our .env file. So if we go into our server, you can see there's no .env file because we don't want to expose our credentials into our GitHub repo. And in our production server, we're not going to import our environment variables in the same way we did on our development server. Instead, what we're going to do is we're going to set it for our specific user or globally across the entire Linux operating system. So let me walk you through how to set an environment variable. It's pretty easy. And the way we set an environment variable is by typing the command export, and then we pass in the key and value. So if we want to create a environment variable called test, and we want to set that equal to a certain value of, let's say, hello, right? We can hit enter. And so at this point, that environment variable is set, and we can do a print nv, and that's going to print out all of our environment variables. And you'll see there's actually quite a few environment variables. Let's see if we can find ours. And so there you go. It's set right there. And obviously, if you don't want to look through all of those, you can always do a pipe grep, and then you can search for test. But this is going to be case sensitive, so I always like to do a -i. And so, yeah, you can see this environment variable is set. Now, if we want to remove an environment variable, we can use the unset command. So we can do unset, and then we can just type in the name of the variable. So if I do unset test, and now if I do that print nv command again, you'll see it's not there and it's been removed. Right? And if we go back to our code real quick, you'll see in our environment file, we've got quite a few environment variables, right? We've got 1, 2, 3, 4, 5, 6. We have 6 different environment variables. It would be a little bit of a pain to have to kind of, write each one out individually. Like we'd have to do, export. What was it called? Port equals, and then 3001, right? And then we'd have to do export PG user equals Postgres. And we got to make sure we wrap it in quotes. All right. And you can start to see that this is kind of a bit cumbersome, right? Because we actually don't have that many environment variables in our project, but other applications could have a ton of environment variables, and to have to go in manually and type these out is a little bit cumbersome. And so instead, what we can do is we can create a file, and then we can kind of import that file and then load up all the environment variables that are declared in that file. And I'll show you guys how to do that. So I'm going to go to our home directory, and I'm going to create a file called .env. Now, the location of where I'm putting this file does not matter, and the name of the file does not matter. You can name whatever you want. I'm just going to name it .env because why not, right? It's pretty clear what it is it's used for. The only thing I recommend is if you're going to store your environment variables in a file, do not put it in the same directory as your application code, because you don't want to accidentally check it into GitHub for some reason. So it's best to store it someplace outside of your application code. And that's why I'm putting it in my home directory. And so I'm just going to do vi, and I'm going to call it .env. So that's going to create a file called .env. And what we can do is we can just take all of these and just paste it into here. And there's going to be a couple of changes that we need to make. So we got to put the export at the front, and we got to wrap it in quotes. And we're going to have to do this for all of them, so just bear with me. All right, and so now what we can do is I can do source, and then the path to the file that we just created. So it's going to be in the current directory, so I can do source.env. And now if I do a print nv, and I'm just going to grep for anything that starts with PG, because all of my environment variables that I declared in that file all start with PG. And, ignore this massive one right here. But you can see we got PG port, PG password, PG user, PG database, and PG host. So all of them got imported. You can see that doing it through a file is a lot more convenient. So if you need to make a change, you just go into the file and make that change. However, there's one other thing that we can do to make this a little bit easier, and that is I don't like how we have to go in, add in, export, and then put the quotations. Wouldn't it be nice for us to be able to just take the environment variable file that we have in our code and just copy and paste it directly into this file and be done with? And we can do that, and it's pretty easy to do that. There's only one modification that we have to make, and that is First of all, let's delete all of this, and I'm going to go back to our code, and I'm just going to copy this directly, show you how much easier this method is. And now what we can do is we can run this specific command. It's going to be set -o all export semicolon, and then source, and then the path to the file semicolon, and then set +o all export. And what that'll do is that'll take that environment variable file where we don't have the export or the quotations, and it'll automatically add that for us and turn them into environment variables. So they were already set when we ran it previously, but just trust me that this method will also do the same exact thing, and it'll make your life a little bit easier because you don't have to go in and change it, and you can just copy it directly from your project code. Now that's great and all, and this is going to be the method that we use moving forward. However, there's one issue. These environment variables will not persist or reload. So if our machine for some reason reloaded, it would essentially crash our application, and I'm going to prove that to you guys. So if I do a sudo reboot, our machine's going to reload. Give it a minute or two for it to power back on, and then we'll log in, and I'll show you guys those environment variables will be gone. All right, so let's log back in now. And if I do a print nv pipe grep -ipg, you'll see that none of the variables that we had defined before remain. So it looks like after reboot, they get removed, just like I said. And so what we need to do is to make sure that these environment variables get loaded up upon reboot. First of all, let's go to do an ls-la. If you just do an ls-l, that's going to print out all the files, but it's not going to print out the hidden files. So if we do an ls-la, it's going to print out the hidden files. And so here, there's two files that we can modify to make it so that those environment variables get loaded upon a reboot. And the first one is going to be .profile, and the second one is going to be .bashrc. Both files do something a little bit differently, so I recommend you guys read into it, but I'm going to use the .profile file. And so I'm going to do a vi profile .profile. And all we want to do is we want to go to the bottom of the file, and we want to add that export statement that I gave you a few minutes ago. Where is it? It's going to be this command right here. So you remember set -o all export, then you do source, provide the path to the environment variable file, and then this part at the end. So we can just copy this, and we'll paste it in here. Now, when you do this method, technically the current terminal, this session that we have, will not have the environment variables. If I do a grep -ipg, not there. But all we have to do is just exit out and then just reconnect. And now if I do a print nv pipe grep -ipg, you can see all of those environment variables are now set. All right. And, if we reboot the machine, you'll see that they'll persist. They'll get loaded up upon every reboot. The only other thing that I want to cover is make sure that, when you guys do this, make sure you update the password and the username. So yeah, we actually want to change this. So instead of Postgres, it's going to be the Ubuntu user. Although technically the Postgres user does exist on this, so we could use that. We would just need to make sure that we have a password defined for it. But I'm just going to change this to be the Ubuntu user. So let me go back into the .env file, and where is it? Change him to Ubuntu. And once again, those changes won't take effect. You'll have to I just like to exit out. It's just a little bit easier. There is a way to do it on the command line, but I'm too lazy to figure out what that command was. Let's do a printenv pipe grep minus IPG. And now it's set to Ubuntu. So we've got our environment variable set. There's still a few more things that we have to do. We're almost done though. All right, so the next thing that we want to do is we want to set up the firewall on our Ubuntu machine. And you might be wondering, well, didn't we do that in AWS? Right? If we remember that security group that we modified when we clicked on this, and now it has those extra rules. Remember, this is the firewall within AWS. So this determines what traffic is even allowed to our EC2 instance. But as an extra layer of security, it's also recommended to set up a firewall on our Ubuntu server so that if for some reason, if maybe you don't deploy this on EC2, you deploy it on like a DigitalOcean droplet and they don't have firewall services, you want to make sure that this box or the operating system doesn't handle traffic it doesn't need to. So you want to make sure that we only allow 3 types of traffic. And it's going to be the same 3 types of traffic that we allowed here. We want SSH traffic so that we can obviously connect to it. We want to allow HTTP traffic as well as HTTPS traffic. And so to work with a firewall, you use a service called UFW. So if I do a sudo UFW status, you'll see that it's inactive, which makes sense. That's the default behavior. And we want to enable certain firewall rules. And to do that, you do sudo UFW allow, and then you pass in the rules that you want. So if you want to allow SSH, all you have to do is just type in SSH. They make it really easy for you. Then we also want to do a sudo UFW allow HTTP traffic, as well as sudo UFW allow HTTPS. And there you go. The last thing that we have to do is enable it. So you do sudo UFW enable, and then just hit Y. So it's enabled. And so if you do a sudo UFW status to see the status now, you see it's active and you'll see all the rules that are in place. So it's going to allow port 22, and you can see the action is allow and from any IP address. There's obviously a lot of configuration changes and customizations that you can do to this firewall. You can say like, oh, I only want to allow TCP traffic on port 22, but only from my house's IP address so that no one else can even try to access it, right? But we're just going to keep things simple. And just to go over some of the other lines, this is HTTP. It's going to allow HTTP traffic. It's going to allow HTTPS. And then we have the IPv6 version of those first 3. So whether it's IPv4 traffic or IPv6, the firewall can handle it. All right, guys. So we're almost done. The final step is to set up SSL. And if you take a look at our app right now, you can see that Chrome automatically declares it as not secure. So it's using HTTP, which is port 80. It's not secure. It's not encrypted. And so we don't get that nice green lock or padlock. And so we'll set up SSL. It's very simple. Let's Encrypt does it all for you. There's like 2 commands that you have to run. But once we do that, it'll only use HTTPS. And it's great because even if a user explicitly sends traffic using port 80 with HTTP, it'll automatically redirect it to HTTPS. So it's going to make our site secure. That's how most websites run nowadays anyways. But if we go back to the README, there's a step-by-step procedure on their website. So you can just click on this link. And what's great is it actually configures Nginx for us. So we did the basic Nginx configuration, but normally when you generate certificates for SSL, there's a lot of extra configs that you'd have to put in place within Nginx. And then to set up the redirects, you'd have to do all of that manually. But certbot and Let's Encrypt, these guys have made it so that it automatically configures it for us. So here, just make sure that you set up Nginx. If you're running a different web server like Apache, you can select that and then select what Ubuntu version you're running. And all we need to do is we'll start off by installing certbot. So we can just copy this line right here. All right. And then, we're just going to go down the list, just copy the commands. And then this is going to be the last command that you need to run, the sudo certbot --nginx. It's going to be an interactive prompt. And let me clear this so we can get to the top. All right, so first thing it's going to ask for is your email address. So you want to put a valid one. All right, you have to agree to the terms. And then this is just asking, what is it asking? Would you like to send you email? No, don't send me email. All right, and what's great is it looks through our Nginx configs and it looks for all the domains that we would potentially want to set up SSL for. So we've got 2 domains. We've got the sanjeev.xyz and then the www version. But if you configured extra server blocks, it would also list those out because it parses through all your Nginx configs. And so you can just go in and select which specific ones you want just by typing in the number. And then you can do a comma and then like 2 if you want 1 and 2. If there's like a 4th and a 5th one, you can just add those. If you leave it, whoops. Uh-oh, what happened here? I'm going to cancel out of that. And we'll run that again. And so if I leave this blank, it's going to automatically select 1 and 2. So I'll just leave it blank. And it's going to generate the SSL certificates. And it's going to do some verification. So it actually wants to make sure that you own both of those domain names. So if you haven't already pointed the DNS to your server, this part would fail. So make sure you set up DNS before you do this step. And then you'll see that it's successful now. So if I now go to my React app, let's go back to our root. And it looks like we've run into an issue. Let's make sure. Well, that shouldn't matter. Sudo ufw status. Oh, that's right. So after we set up SSL, we can only use our domain name. So if I go to sanjeev.xyz, you can see that it now takes us to our website. And you see that we have the green padlock. So the connection secures using HTTPS. And if I force it to go to HTTP, the great part is it'll automatically redirect it to HTTPS. So now our website is secure. The last thing is it looks like there's still an issue with accessing the database. So let's tackle that in the next step. But actually, before we do that, I want to quickly just go over what were the config changes that Let's Encrypt actually made to Nginx. So if we go to /etc/Nginx, sites available, you'll see a decent amount of config changes. So if we do a cat sanjeev xyz, so you remember the listen statements on port 80 at the top? Those are gone. They moved it down here, but instead of listening on port 80, remember this is going to be handling HTTPS traffic, and the default port for that is 443. So this is just saying, listen, we're going to only listen on port 443. And then these are the SSL certificates and their locations. And so Let's Encrypt creates those SSL certificates. It stores them in those locations. Then we just got to tell Nginx how to reach them. And then don't worry too much about the other configs. The last thing is, I think this is where the redirect happens. And so it just basically says, if traffic gets sent to, sanjeev.xyz, you want to make sure that you redirect it to HTTPS version of that. And so that's all. Yeah, you can see it's listening on port 80. So if you receive any traffic on port 80, redirect it and send it to HTTPS on port 443. So those were all the changes. In the next section, let's tackle why we can't access our database. All right, so, if we take a look, we can see that, we're not loading the restaurant data. So it looks like there's an issue with accessing our database. And if we go to inspect and then go into network and then just hit refresh, you'll see that we send a API request and we don't really get a response back. And so that's our issue with our backend. It's most likely because it can't access the database. An easy way to check the logs, if you do a PM2 logs, it's going to print out any logs that your Node app is printing out. And you can see that there's a It gives us a little snippet of that, and we can see an authentication failure for connecting to our database. And so let's just double check that our environment variables actually got set. We do print pipe grep minus I PG. We do see all of them set. Let's just double check. So PG port 5432, password 123, and Ubuntu, Yelp, localhost. And I'm wondering if we have to do a PM2 restart. So if we do PM2 status, I'm wondering if we have to restart the process so that the environment variables can be, associated with the Node app. So if I do PM2 restart 0, let's see if that works now. Yep, that was it. So we just had to do a PM2 restart after we made those changes to the environment variable. And so now this works. Let's click on a restaurant. Looks like it works. And here, an important thing is when you go to another route, let's do a refresh directly to that page just to make sure that Nginx is working. And it is. So there you have it, guys. We have now successfully deployed a full stack Pern application. Now, I do want you guys to keep in mind that there's obviously a lot more things that we can do when it comes to preparing this server. There's a lot of security vulnerabilities that we could address. I just wanted to cover the basics of how to set up Nginx, how to set up the back end, the front end, and a few other things like that. But there are certain things like, I think anyone can directly access the database right now as it is. So you would want to make it so that only, your application can access the database and no one else. There's a lot of other things, especially from a Postgres perspective, that you guys can do to make, this production environment more secure, more hardened, and less vulnerable to attacks. But I think this is a good starting point for you guys, and hopefully you guys now have a basic understanding of how to deploy applications. And if you guys in the future need to make any modifications, it's just, a few Google searches and you'll see that there's only going to be some minor changes that you'll probably have to make. And hopefully you guys enjoyed this video. And if you guys like these deployment videos, I'm more than happy to do a few other ones. This one was a full stack app on, Ubuntu machine. But if you guys want me to do videos on deploying to like Netlify, Heroku, GitHub pages, maybe AWS S3, I think a lot of those videos, they wouldn't take too long. And if you guys think those would be helpful, I'm more than happy to make some videos on those topics as well. Just leave a comment, let me know. And if any topic is popular enough, I'll be more than happy to make a video.